Hello and welcome to this video where we'll go into Matplotlib annotations. So this is quite interesting because before we learned a little bit about Matplotlib fundamentals, and using annotations you can write arrows, you can write labels, and you can place them wherever you want in your visual. The advantage with that is that you can place them quite near to where it applies. So instead of having, for example, legend to show some information, you could annotate where the data actually is. And this makes it more powerful since you will use the principle of proximity to show that things are close to each other. So I'm here in Visual Studio Code and you can see that I have data here. And this data is the 19th century census immigration pop metro. So it's basically data about immigration in 1900s into US. And here you can see, for example, we can open preview here. And you can see there's a lot of different states in US and how many foreigners, etc. And this data is available in the repository, which I will link in the video description so that you can download this data and work with it yourself. So let's take out the terminal and start with UV then, so that we have a virtual environment. If you already have it, you don't do UV then because then it will overwrite it. Instead, you'll just activate your virtual environment. So I activate my virtual environment and then I install. So UV pip install ipykernel. I need pandas, duckdb, and matplotlib. And if I need something else, I will install it on the way. So let's work with this now. So I'll call this matplotlib annotations.ipnb, like this. And kernel, Python, virtual environment, markdown. I'll call this annotations. Actually, we can do like this to make it a little bit cooler. Okay. So first we'll start off with some exploratory data analysis. So import pandas as PD, import duckdb, and then df equals to pd.read CSV, and I will read from data / 1900 census immigrants pop metro.csv. So df looks like this. Okay, first time it takes a little bit longer because it haven't done any caching yet. Okay, file not found. Why is that? Let's see, data / 1900 census. Okay. Census like this. Ah, perfect. Now I have the data. So always when you have a new data set, you will try to understand it. So doing some exploratory data analysis, df.shape to see how large it is, 16150. df.columns, for example, you can see all the columns we have. Yeah, there's a lot of countries here. Cool. Okay, what else can we do? We could do df.info to see if we have any null values. What you can understand from here is that this is a very wide table. So we have a lot of columns. So you can see a lot of columns here. We can see there's some null values here. And what you could think of is like here, there's a lot of nan, right? Null values. And for example, here, city Akron, state Ohio, and there's nan in Atlantic Island, nan from Asia, etc. So then here you should probably talk to domain experts, but by thinking ourselves, it could be a viable solution to just fill the nuns with 0, because if it's a missing value, then we assume that there's no immigrants from there, or there's no records of it, right? So we can just fill the none. So .fillna with 0, and you can see that they become 0 here. Okay, so df fillna. And then we can do df head to see this. Yes, you can see that now we have the zeros and filled it out. So I will do df.info. And from df.info, you can see that, for example, we have Denmark, it's object. we can do info and we can pick out a few countries. Denmark, Sweden, Norway, Finland. Let's see, do I want anything else? I want to have total also. Total foreign born. So these are the different columns that I would like to work with. I want to focus on the Nordic countries and also have a reference to the total number of foreigners. So what we can see right now is that they are objects, but I want to change them into int so that I can work with it, visualize it. So that is my strategy. I want to take this. So I want to pick all this, it out. I will call this columns to change type. And if I choose here columns to change type, we can see we get the same results. So in order to change the column types, we can do like this. We can go through each of the columns and then we can do string.replace. And here we don't have so many columns, so it's totally okay to loop it through. So for column in columns to change type, df of column equals to df of column dot string dot replace. So we need to replace the comma, because actually if you look into the data here, there's a comma here. That's why it's 1,000 comma. It's object, so it's string type. So we replace it, string dot replace comma with nothing, and then dot as type in, basically, just like that. df.info. Now we have an error, cannot convert float none to integer. Okay, I got it. So this is quite a strange error, you might think. That is because, what did we do before? We replaced it with 0, while the ones with a comma, they are objects. So when I do .str, it means that it don't have an str, so it becomes a nan value. And when it becomes a nan value, we cannot do as type int. So you need to actually do like this. Make it into 0, but a string. And when I run all now, we can see that this one works. So actually, I don't want to choose all of df info. Instead, I will do columns to change type, and then I will run all. And you can see all of these, they are in. Good. So now we have changed this. So let's pick out the things we want now. So I want to pick out all my Nordic countries. And I want to sum all of them to find the number of foreigners for each of the countries. And I want to group it by each state. So if you look into df.head, you can see that we have cities, we have states. You can see there are several cities in each state, or in some of the states. And then we group by each of the states to find which state have how many number of Swedes, Norwegians, Danish, Finnish, Nordic, and total foreigners. So this we can use to create bar charts later, so that we can compare which countries have the most of the Scandinavian immigrants. And also for historical reference, in this time there were a lot of Scandinavian people going to United States because it was hard to grow food at that time. Okay, so let's create a query now. So duckdb.query. So we do a with statement here. So a CTE with Nordic, select state, sum of total foreigners, Sweden, as copy this a few times, Norway, Norwegians, Finland, as Denmark, as Danish. Okay, like this. We select this and then state. We group by each of the state. And then we have, so this is our CTE. So afterwards we could do like this. From Nordic N, select R, and we can see what we get. So now you could see, let's see, select star, total foreigners, Swedes, Norwegians, Finnish, Danish. And here are all the states. So 39 states. Okay. Based on the data, we have 39 rows. So we have 39 states. And we have total foreigners, Norwegians, and Danish here. So based on this one, I want to also pick out the number of Nordic. So we do select star and then plus n dot Norwegians plus n dot Finnish plus n dot Danish as Nordic. And then we order by Nordic. And we have descending. Okay, perfect. So now we see these are the states which have the most Nordic people. So we have Illinois, who have this many Nordic. Minnesota has this many, etc. We take .df as well. Make it into data frame. So this is our query. So df then Nordic equal to this. And then we have df Nordic here. Cool. So now we have sorted out this. We have filtered out and we have done some calculations here to pick out all the Nordic countries and each of the Nordic countries and total foreigners for each of the states. And we have grouped by the states to sum the number of foreigners there. Okay, based on this, it's time for doing some plotting. For example, we could get the top 3 Nordic by doing like this. Top 3 Nordic equals to df Nordic dot drop axis equals 1 dot set index. We set the index to state and we pick out dot head 3. So we get top 3. Note that they were already sorted by the number of Nordic people there. So now you can see that we have Swedes, Norwegians, Finnish, Danish, and state. And then we have the values here. If you think about this, it looks a pivot table, which we had in a previous video where we gone through Matplotlib, line and bar. And based on this one, we can create a stacked bar chart so that we have state, the index here. These are the x-axis and these will be the y values. And you can see for Illinois, we will have these as y. And for Minnesota, we'll have these as y. And New York, these y. So let's plot this. Import matplotlib.pyplot as plt. So let's create x equals to top 3 Nordic dot plot. Kind equals to bar. Big size equals to 12,6. X dot set x tick labels. Let's start with this one to see what we have. You can see we have Illinois, Minnesota, and New York. And we have a legend here. And we will also make it into x dot set x tick labels. Top 3 Nordic of index rotation equals 0. So I just wanted to rotate it. Okay. And actually we will reuse this one. So I will do like this, def Nordic plot I'll make it into a function. And I will return x, fig, comma x. Let's see, what is fig then? Fig is equal to x dot get figure. And then we could do like this, comma x equals to Nordic plot. So I will just type x here and you can see this graph. So now we can reuse this Nordic plot. So I will use this one and I will make a little bit of annotations on this one. So first, let's understand it a little bit. So we have x. We can see it's a axis with x label state, okay? And then we have x.containers. What does this mean? We have 4 containers, each with 3 artists. Okay, what is what? So 4 containers. Think about this. So here is 4 containers. So we have blue, orange, green, and red. So these are the 4 containers, and you can see blue happens 3 times, orange 3 times, and green 3 times. So we can conclude that each artist is, this one is an artist, this one is an artist, and this one is an artist. All Norwegians is 1 bar containers, all Finnish is 1 bar containers, and all Danish is 1 bar containers. So we have 4 containers, or 4 bar containers, and each of them have 3 artists. An artist is basically the single bar, like the rectangle. Okay, so if I want to get something special, I can do like x.container, x.containers of 0. Then I get the first bar container, right? Which has 3 artists. And if I want to pick out the 0th artist, I will get this object here, matplotlib.patches.rectangle. So this is basically what needed to create this visual. So then I could do like this, x.container 0 of 0 dot get height. And then I get the height of this one, 57,158. Yeah, it makes sense. So close to 60,000. So then I could do similar thing. Copy this one. And instead of get height, I could get x. And we can get minus 0.25. So it's minus 0.25. So for getting the x value, you need to go negative 0.25 to get to here. Because I think here is 1 somewhere. By using these, you can find its relative position for the x value. So it's a little bit different from one graph to another. But using this knowledge here, we can create annotations. Annotate with arrow. So I could get all the bars by doing this. Swede bars, Norwegian bars, Danish bars, Finnish bars. Because we have Swedes, Norwegian, Finnish, Danish, right? Actually, a little bit different. Let me see. We have Finnish, Danish. So it must be here. Finnish, Danish bars equals to x.containers. So here we are just unpacking this tuple. If I do Swede bars, we can see it's a bar container with 3 artists. So x equals to Nordic plot. We need to do like this. Fig, x equals Nordic plot. And then based on this one, let's create our annotation here. So to annotate, you do this x.annotate. You type in the text equal to, for example, Swedes. And then you pick the x value. For example, if I pick 0 here, the x value, x and y, needs to be in tuple or a list. 0, for example, comma, say that I want to have this one, 40,000 around. 40,000. Let's see. Need to type it out here. xy equals this. Okay, so 0 was in this place here. Then maybe it's 1. Yeah, 1 around here. So maybe 0.8. So then I get the text here. So it's x comma y. So if I want to move it up, I put 50,000, and you can see it's 50,000, and here's the 0.8. I do 0.7, for example. So that is how you annotate with text. So let's also create an arrow. No, actually, we should do an arrow here. Arrow props equals to arrow props. And we need to define what arrow props is. Arrow prop is basically a dictionary. So dict of arrow style. What do we want to have as arrow style? I want to have this. So that is a line and an arrow in the end. And we have connection style. Connection style equals to arc 3, and then we have radians, how many radians you want, for example 0.3. And then you choose the line width. Line width equals 3, for example. So this is my arrow. So the arrow will be placed in the XY. Also the text will be placed in the XY. You could do a text offset. So you do XY text equal to somewhere else. For example, if I pick 0.7, 60,000, you can see that the arrow goes to 0.7.50,000. Actually, I want to make it a little bit thinner. So if I want to have the arrow going down to here, it's like 35,000, right? 35,000 and maybe 0.6. Okay, so 0.7, 0.8 maybe. Yeah, exactly. And then we can lower this one, maybe 50. Okay, so looking good. The arc gives us this one, how it should be arced. And then radiant gives us how many, radians is basically an angle. So how much do we want it to be angled? And you can play around with this. For example, 0.5, you can see it becomes more curved, more angled. And also if you want to have it other direction, you do negative. And then you get it to here. But I want 0.3, it looks good. I want to have it in 0.6. Like this, and then here we maybe go 45,000 instead. Ah, looks good. So this is the way to annotate it. And you can change also the font size. Font size equals to 12, for example. And you can see it becomes a little bit bigger here. And yes, I want to change this. I will go up here and change this to a little bit bigger. Actually, I prepared a little bit bigger, so 6, and then run all. Yeah, exactly. Okay, looks good. So now we need to add the other ones as well, but I don't want to in all of these. Let me actually move myself a little bit. I'll move myself up here. The idea is that I don't want to put this in by trial and error and test it out a lot, because that kind of makes it a little bit like we want to reuse the code. We don't want to repeat the code all the time. So I don't want to copy this for one for Norwegian, one for Finnish, and one for Danish. So I want to keep the code a little bit dry. So don't repeat yourself. So what to do here? I want to pick this out automatically. So what can we have? We have Swede bars, right? So we could think of an idea that I will copy this just to show you. In my lecture note, it's a little bit cleaner. So here, I'll run this again. We will pick, instead of xy here directly, we could do like this. Xy equals to Swede bars dot get x Swede bars dot get height. So then I can take up, I can place in xy here. Let's see, bar container object has no attribute get x. And let me see why. Okay, so if we go into Swede bars, bar containers, right, we need to go into the 0 of the bar container. Yeah, exactly. Yeah, we choose which one of them. So for example, I go into 1, and this rectangle we can do get x. So Swede bars of 1. Yeah, exactly. So based on this, I have an xy, and I could pick the xy of text. Instead of writing like this, I should have an x offset and a y offset. And doing this, I could do like this, xy of 0 plus an x offset, comma, xy of 1 plus an y offset. And then we need to pick what is the x offset and what is the y offset. So for example, we could pick x offset equals 0.3, y offset equals to 5,000, for example. And it looks like this. Not really ideal, but quite a good start. So what could be better here? We could do an x offset of minus 0.2. So if we do 0, then we get here. If we do minus 0.2, we get to here. And this is a little bit better. So we can actually go for, we can do like this. In order to get it into the middle, instead of writing xy directly, we could do like this. We make it into a tuple and we do xy of 0, which is the x value, plus some kind of offset for x, then comma for y, xy of 1. And you can see, okay, 0.1 too much, 0.05. Better. So now you have the Swedes, and it's pointing towards the middle of this rectangle. So that we can reuse this. So let's create a function of this. Def annotate Nordic. We'll put in the bar artist, because instead of putting Swedes directly like these Swede bars, then we put in a bar artist. And we put in a text that we want so that we can change it. X offset equals to minus 0.2, for example. Y offset equals 5,000. Actually, I pick 6,000. Okay. And then I don't need to have this X offset and Y offset anymore, because these are passed in as parameters. Let's see, this one should have like this. And let's see, bar artist instead of Swede bars. We have bar artist here. Instead of Swede bars, we have bar artist. Okay, what else do we need to change? Offset. Yeah, I think it looks good. Text we can change also. It shouldn't be hard-coded. It should be text. And then annotate Nordic. If I place in bar artist, I place in Swede bars of 1. I place in Swedes And this should give the same results. Yeah, exactly. It looks quite similar. Then I can do similar here. Bar art instead of Swede bars. I'll put, for example, Norwegian bars. And I don't want to annotate first one. I want to annotate this one in Illinois. So of 0. All you guys Norwegians. You can see it looks like this. But I want to place it a little bit to the right. So I will have an X offset. X offset of 0.3 maybe. Okay, didn't look so good. 0.2. Y offset, let me see, 35,000. So 5,000 up, 6,000 up, 10,000 up. Maybe. Yeah, okay, looks good. I want to change the art so that it goes in the other direction. And to do that, we have arrow props here. So we can do an F string here. And instead we can place in here radians. The radians equals to minus 0.3 if X offset less than 0. 0.3. Because we had minus 0.3 when X offset is less than 0. Because in Swedes, we had less than 0. In Norwegians, we have larger than 0. Then we want it in other direction, right? So now you can see it becomes in the direction that we want. And I'll do a similar thing here. Copy this one. Instead of Norwegian, we'll put in Finnish bars. Finnish bars of, for example, this one, New York 2. Finnish. Set 0.2, fine. Let's try 5,000 first. Yeah, Finnish was this one. Let me see. We can do with less offset here. Make it a little bit higher. 7,000. Yeah, good. You can see it's very easy to control when you have a really nice function like this. Copy this one. So Danish bars. Danish. Let's see. Let me take this bar here. So it's the 0th bar. Yes. Maybe 4,000. Okay, maybe more. 6,000. Yeah. Looks good. And then here we can remove x.legend not remove like this. As here you use proximity principle and annotations to annotate each of the bars so that which bars correspond to which countries. Okay, and then you could do like a fig.type layout and fig.savefig, and we can save it into figures / annotate .png, and we don't have a figure, so we need to create a figure folder. Figures. Okay, and you get it here. Cool. So I'm happy with this annotation. So I hope that you learned some annotation. Okay, so in this video we've gone through Matplotlib annotations and doing annotations with arrows and text labels. It's a little bit tricky if you don't really understand it, but when you understand it in depth, you understand the containers, the artists, and then you can easily create a function out of it and manipulate the offset and manipulate the positions. And when you have the function, it's really easy to annotate wherever you want, and you can even control the angle of the arrow so that it looks good. So with this, I would like to thank you for watching this video and see you in the next one. Bye.